Hi everyone, welcome to a topic called logarithm. Whenever I teach this topic in class, I've realized students really are scared of this topic, logarithm. As soon as they hear that, they want to leave this topic. Let's not worry, try to relate it as far as possible to indices, and I'm sure you're not going to find the topic very difficult. Let's see what I mean by that. So, initially we're going to start with that only, how to convert a indices question to a logs or vice versa. So, if I have a raised to x is b, a raised to x is b, how do you write it as a log? You can write it as log b to the base a is x. So, please understand that log b to the base is equal to x. Think of it only as indices, a raised to x is b. Let's take that as an example. So, when I say 2 raised to 5 is 32. Now, if 2 raised to 5 is 32, it is as good as log 32 to the base 2 is 5. So, comparing them both is very easy. So, if you have a log question, a simple log question, you can actually convert it to indices and solve it like a complete indices question also. Let's take vice versa, how to convert a log to indices. Obviously, exactly the same thing. If log b to the base a is x, then a raised to x will be b. Take an example. If log 243 to the base 3 is 5, then 3 raised to 5 is equal to 243. Right, so that gives you the conversion of how to convert logs to indices, indices to log. Let's take some law of logarithms which also come from law of indices only. First one, log 1 is always 0. Now this is irrespective of whatever base I am talking about, base a, base 10, base 5, log 1 will always be 0. Log a to the base a will be 1. Obviously, log x to the base x is 1, log 5 to the base 5 is 1. Third one, log mn to the base a can be written as log m to the base a plus log n to the base a. So, look very carefully, when there was a multiplication to a base a, it opened up as a addition. Log m by n to the base a will become log m to the base a minus log n to the base a. Log m to the base a raised to r, or sorry, should be read as log m raised to r to the base a, can be written as, so the law states here that the r will come in the front. So it can be written as r into log m to the base a. Next one, log m to the base a can also be written as log m upon log a to any constant base. Let's go through that once more. Log m to the base a can be written as log m upon log a to any constant base. Next one would be log b to the base a multiplied by log a to the base b. What would that be? Now think from the previous concept. Log b to the base a can be written as log b upon log a, while log a to the base b can be written as log a upon log b. It could, all four could be to any constant base. Everything cuts out, so the answer is 1. So what is the concept? Log b to the base a multiplied by log a to the base b will be 1, which can also be taken ahead and said that log b to the base a is 1 upon log a to the base b. Next one, slightly difficult, but we are going to try and take the steps as we go ahead. So that's log b raised to alpha to the base a raised to beta. I can write it as log b raised to alpha upon log a raised to beta. The alpha comes in the front, the beta comes in the front. So we have alpha log b upon beta log a. Log b upon log a can be written as log b to the base a. So hence our answer becomes alpha by beta into log b to the base a. Next one, a raised to log n to the base a. What will that become? The answer is n, but again, let's not just take it, let's understand it like a small proof. Suppose if I start by saying let a raised to log n to the base a be x. Take logs on both sides, what will you get? You will get log x is equal to log of a raised to log n to the base a. Again, according to the properties of log, that whole thing can come down. So we will have log x is equal to log n to the base a multiplied by log a. Log n to the base a can be written as log n upon log a multiply by log a cuts, and we are left with log x is equal to log n, and therefore x is equal to n. So the last two properties may were slightly more difficult the laws of logarithm, but these are very, very important laws of logarithm, and we'll now take some examples to see the same. Let's take the first example. Log of 5x minus 10 minus log of 12 minus x is equal to 1 plus log 7. Now, since there is no base given, here I am going to assume that the base was 10. Now, what can 1 be written as? 1 can be written as log 10 to the base 10. Now, log a minus log b will become log a by b. So, that becomes log 5x minus 10 upon 12 minus x. 1 has become log 10. So, it will become log 10 into 7. The plus becomes multiplication. Now, the log goes off on both sides. So, we are left with 5x minus 10 upon 12x minus 7 is equal to 70. Divide both sides by 5. You will be left with x minus 2 is equal to 168 minus 14x. That is 14 into 12 minus x. We have divided both sides by 5. 15x is equal to 170. X is equal to 170 upon 15, which will become 34 by 3. So, pretty simple question on logs. That is what I was telling you all. Normally, students fear that the questions are going to be very difficult. It's not so difficult. A very straightforward question. Let's take one more question. If log 2 is x and log 3 is given as y, find log 144 in terms of x and y. So, in short, first I'll have to do 144 in terms of 2 and 3. What is 144? We know it's 12 square, which can be written as 2 raised to 4 into 3 square. Take logs on both sides. So, we get log 144 is equal to log 2 raised to 4 into 3 raised to 2. The multiplication will open up as plus. So, that will become 4 log 2 plus 2 log 3. The 4 came down from the property log m raised to r is equal to r log m plus 2 log 3. What was log 2? X, and log 3 was y. So, hence our final answer is 4x plus 2y. So, pretty simple one again. Let's take example 3. Log of x minus 2 to the base 3 to the base 5 is 1. Find x. Obviously, if you had options for this sum, one way of doing this sum could have been use of options. But here we are going to try and explain the question without options to you. Suppose if I say let log x minus 2 to the base 3 be a. Log x minus 2 to the base 3, that much part as a. So, hence, what will the question become? Log a to the base 5 becomes 1. Right? We have taken that whole thing log x minus 2 to the base 3 as a. Now, solving this, converting this to indices or whichever way solving this, we should know a will become 5. If log a to the base 5 is 1, a will obviously be 5. Substitute this value back in the question. What was a? So, we get log x minus 2 to the base 3, which we had taken as a, equal to 5. Again, convert this to indices. So, x minus 2 will become what? 3 raised to 5, right? According to first concept of logs, how to convert logs to indices, x minus 2 will become 3 raised to 5. 3 raised to 5 is 243. So, x will become 243 plus 2, x is equal to 245.